Hello folks, I keep looking to the right, don't ask me why. Anyway, I'm going to go ahead and try this again. Let me turn the radio down, and push my buttons. I'm in my car right now. And every time that I've been in my car before, I've made videos and I've encountered certain things, certain events along the way on the road, and due to the way the people were driving, it kind of didn't come out quite right on my video. So I'm trying to avoid that. This is a good time for me to go ahead and share my thoughts. Now, I did save those videos, so if for any reason, COVID-19 takes me out, there will be access to my information that, anybody can get a hold of. Possibly you go through the family or whatever, if it ever comes to a point like that, right? In case people at some point in time actually become interested in knowing the things that I thought when I was alive, that type of thing. So I'm going to go ahead and start talking to you about stuff, and I delved into a little bit of time travel and how you got to be able to navigate the universe to actually go back in time to a legitimate location, because everything moves and nothing is ever in the same place it was when it happened. So you have to take that into consideration, and you also have to take into consideration a lot of other elements that change where you would land if you were to go back in time. So, but that's quite a bit farther, and so what we're going to do is I'm going to go ahead and talk to you a little bit to start with about the universe. It'll be repetitive if you've listened to all my videos that I've made, but those are in my archive. So hopefully my phone doesn't cut out on me. I pretty much cleared it of all the other stuff that was clogging it up. And as it turns out, I'm going to have to buy a new computer because my computer is so slow. It's not working with any of these programs that would allow me to show you guys my graphics and talk to you at the same time. So I got to go buy another computer. And then we'll get that stuff started. Sorry it's taken so long to try to get my things in order to be able to share the information as I would like to share it. The information that I do have it's there, and if people take the time to look at it, you'll see what it is exactly that I'm talking about in terms of reading and identifying different things about the Earth's surface that tell us a story that doesn't necessarily coincide with current scientific views on how the world works. And it gets tied in with all the other differential rotating bodies out there that look just like the Earth, being that they're basketballs, or they look like basketballs, right? And they all have the same common nature. And it's because the vortex really is the cosmological common denominator. You find it pretty much just about everywhere you go, all the way down to the atom. For some reason, my telephone seems to be blinking. Either my phone's blinking or my dome light's blinking. I'm not really sure which. So this is what we're going to do. I'm going to put you down here. You can watch my elbow as I drive, as you do in all... Oh, sorry, I didn't mean to cover my face with my hand. I'm going to put that down there. You won't be able to see my face for very long. Okay, there it goes. All my face is gone. All right, now, I don't like to drive with my hat on typically. And I'm going to go ahead and start driving to work. I'm going to turn my dome light off here, pushing one of these buttons. So basically, I'm going to turn my radio off. I'm going to turn my heater down a little bit because it's not quite as cold today as it has been, and I don't have any frost. Yesterday I had a whole bunch of frost in my car, so today for some odd reason there's no frost at all. My windows are clear. I really don't need, even my back window's clear. It's really warm, unusually warm considering how cold it was yesterday morning. Okay, so since it's just a wee bit more quiet in here, or quieter, I guess, I don't know what the right word for that is, I'm going to go ahead and maybe not yell as much. In my other videos, I'm like trying to speak over all of the road noise and vehicle noise that you hear as I'm driving to work, and so I feel like I'm practically screaming, and I know I am because I can see little spit coming out of my mouth because I'm trying to speak so loud with so much, force in my voice, or as the Army would call it, what do they call it? Not projection. It is projecting my voice, but it's not projection. It's inflection. Inflection, that's what it is. All right. So let's see. Now, there's something I want to talk about in terms of differential rotating celestial bodies, DRCBs. So on Earth, you have these 45-degree radial vortices, 6 of which surround the planet that are primary. There are many more vortices, just like you see on Jupiter, but those vortices are sub-vortices, and they are not really completely in tune necessarily with the gyroscopic properties of the planet. And then if you look at the sun, you have the exact same 45-degree perimeters of the or radial perimeters of the vortices. So you have 6 vortices on the sun. And the thumbnail that I'll probably use for this particular video is going to be a thumbnail showing a photograph taken of the sun by the Solar Dynamics Observatory, the SDO, of which was the 4th one that I looked at when I decided I wanted to try to see if I could find a photograph of the sun where I could actually define the some aspect of vortical operation. And it's remarkable. It was the 4th photograph I looked at, and bam, there it was. As far as I was concerned, it was plain as day. And that's remarkable. What that tells us is that it is so much a prominent feature in the operation of spheres that exist in our cosmos that you really don't have to look hard to find it. And it's a lot easier to find if you look at things like the sun and terrain features that you see on the planets, in this case, planet Earth. Okay, so do all planets have the same spiral density type shapes in their terrestrial matter? And the answer is maybe not. But they do to an extent. Like, let's take Mars for what is going on here? Okay, see what I tell you? What did I tell you about weird things going on in the freeway? I got like a convoy of loggers. One of the logger trucks isn't even moving. A bunch of other logger guys are going by and honking at the logger guys that are in front of me trying to get on the freeway. And we've got some truck coming on back here that has whoopee lights on it for some reason, like he's got a extra wide load or something. There's like 500 bazillion, of course that's an exaggeration, right? But this is the most logger trucks I've ever seen in my entire life, all in one space. The logger truck that I passed, that was the trailing truck in this particular row of the convoy, it just now came on the freeway. There's even more logger trucks behind me that were already on the freeway before these guys got on. Crazy stuff. That's enough logger trucks to clear a forest. Yeah. Well, anyway, what was I thinking of before I ran into those guys? I was talking about, doggone it. Let's see. Now he's got his hazard lights on. I almost don't even know what to think about these folks. They don't seem to have a whole lot of experience driving in convoys or something. I'm not really sure why they have their hazards on. They're doing the speed limit. Okay, so anywho, the DRCB operations, the sun. Yeah, I was telling you about, it only took me I only had to look at 4 photographs, and the 4th one was the one I needed that was really good. The title of that photograph from the SDO is something like crazy. I don't know if you heard the guy honking. He was honking at his buddy on the side of the road, which was in a pickup truck. Okay, so anyhow, that's terribly distracting, these guys are. All right. DRCBs are pretty much everywhere, but not necessarily every single object shaped like a sphere is a differential rotating celestial body. Some of them are just rotational celestial bodies. If they are rotational celestial bodies, that means that there's an external force that's rotating them. They don't rotate themselves. Nothing really rotates itself. There's always this external force that's going to be driving that primary rotation. So then you have things that could possibly be the shape of a sphere that are not rotating. And that means that there is no external force that is strong enough to rotate them in any given direction, and they're just basically derelict. But what you do know is every single object that is shaped like a ball, that is spherical in its overall shape, was at one time, in its beginning, in its birth, it was a DRCB, a differential rotating celestial body. That's how these objects that begin to reach a point of solidity appear to us to remain as balls, because they flowed. They had that gyroscopic property when they were being born. And crazy traffic. I am going to work an hour later today because I'm not working 9-hour days this week. So the traffic does get a little bit crazier later in the morning. I'm expecting the convoy to merge to the right. The freeway just went from 2 lanes on the northbound to 3. And no one seems to be going to the right lane. I wouldn't know if they're going to start merging into the right lane or not anyway, because their hazards are on. So why would they be in the center lane with their hazards on, right? So anyway, there's your DRCBs. And there goes a fast mover on my right. Trucker Bob passed me on the left. Now he wants to merge into the center lane. Go ahead, you got it. I turned my headlights off. You have to, with the new automobiles, you have to actually turn your headlights completely off for a moment or two before they actually go off, and you can signal somebody, like truckers, that it's okay for them to merge in front of you. Since they're driving with their hazard lights on, I can't be certain if they're going to merge in front of me or merge right for whatever reason. That just means they'll start moving over. And that's more hazardous than just being slow. Okay. Yeah, so that's pretty much it right there. Now, what I did want to talk about, I'm sorry, I have these lulls going on. This I can't just. There's always something on this freeway that just kind of like throws everything into a loop. Today, it's this massive convoy of logging trucks. Something of the likes of which I have never seen before in my life, ever. I mean, there was that country song, right, about that convoy of trucks, because they were mad about tolls back in the 70s. So this might be comparable to that, but I don't think these guys, I don't know, maybe they are protesting. Maybe that's what it is. Maybe that's why they're driving down the center lane. They want to make sure everybody gets to see them. Might hear about that in the news, I guess. All right. Well, as it stands, anywho, one of the things that I was explaining in terms of gyroscopic properties works the same with the gas giants as works with the Earth. The Earth has two sets of very prominent scores of Jupiterian stripes, and they're extremely obvious mostly in the North Pacific as they cross from the western coast of North America to Hawaii, and they appear to be strongest going between the western coast of North America to Hawaii. But if you actually take a closer look at them, you can begin to trace them around the planet, and you end up with what I'm referring to as Jupiterian stripes. And it's just odd that these two sets of most prominent Jupiterian stripes are actually in the same setting and the same number as Jupiter's stripes. Jupiter currently has 9 stripes along its equator. But if you take into consideration all of Jupiter's stripes and all of Jupiter's rings at the poles, you would have a total of 27. But when we're looking at the side of Jupiter, when we look at Jupiter's profile, all we really see most notably are the 9 stripes, and then you see the poles. But if you look at each pole, you'll begin to recognize, you might not be able to see it if the photograph of the planet is a still photograph. It may be difficult. All you're going to see possibly are different, you might see them, I guess. But if you watch the videos of the north and south poles of Jupiter, you'll realize that those polar rings are also flowing in the opposite directions of each other, just like you see occurring with the tropical stripes. So Earth has 2 sets of these very prominent Jupiterian stripes, and I refer to this period as the Jupiterian 9-stripe period. All right, so what is it that allowed the Earth to score these Jupiterian stripes into the crustal layer of the Earth to make a story or to record a record of an event? The thing is, the only way that these Jupiterian stripes could even appear or begin to appear on the surface, the Earth would have had to have been, at the least, in a state of worldwide liquefaction, where the Earth was malleable, much, much more malleable than it is today. And when you think about it, the Earth really isn't solid. Nothing in the universe is solid. It just seems solid to us because when we beat our head against it, it hurts. And it's not like we can fall through it. We walk on it. I guess I have started raising my voice again to try to drown out the road noise. So it is noisy out here. Yeah, video's still going. So, in addition to the vortical rods that each one of these differential rotating celestial bodies possesses, you also have the stripes, the Jupiterian stripes. Well, where did the Jupiterian stripes exist on Earth? Because they're not on the planet's surface, right? And the scores are not indicative of the Earth's surface rotating around in counterflows of matter. It's underneath. What you do see in the surface are the spiral density fractures left behind by the world's state of liquefaction that turned them into mom's blender. And the scores are basically created by what I'm going to suspect is the asthenosphere. So the Jupiterian stripes on Earth are still functioning at this very moment. The vortical rods are functioning at this very moment, but they're functioning within and underneath the lithosphere and the crust of the Earth. So you don't really see a lot of it occurring above the surface, with the exception of when we have issues with the San Andreas Fault slipping. So as the Pacific Oceanic vortex continues to rotate underneath the lithosphere and actually underneath of the asthenosphere, it's in the mantle, right? And as it's rotating in the mantle in its primary form, it has that overall effect on the crustal surface of the planet. And it builds that pressure up until finally, eventually, every now and then, the crustal layer of the Earth and the lithosphere unlock and release that energy, all that potential energy that's been building up. When they unlock, it slips. Sometimes it has major events that cause a lot of damage, and it takes a lot of money to rebuild the infrastructure that broke down. And sometimes it's just a minor thing where you begin to see the rift taking place and the land separating from west from east, right? And then people stand on the edges of the rift and they're like, because it's kind of scary cool, as long as you weren't standing there when it happened. Now, so the Earth's asthenosphere is where our Jupiterian stripes occur. So they're not really moving the lithosphere, and they're not really moving the crust, but they are scoring the lithosphere and the crust. And I don't know specifically under what circumstances their properties are capable of scoring, but they do. So I'm guessing, well, we got some truckers, and now we have, we got some, we still have a whole ton of loggers. There's a dump truck. One of them was just a cab, a tractor all by itself, nothing else. And these guys finally, I guess, decided to shut off their hazard lights. This is a lot of dudes. There's got to be some kind of a protest or something. Because I can't imagine you got that many guys going to work. There might not be any trees left in the Pacific Northwest by the time them guys get done hauling them away. This log truck has something weird sitting on the top diggity trailer of its Hoogie gadget. And it says, Timber Unity, Washington. Okay, Timber Unity, wait. Well, so do his mud flaps. Say Timber Unity. Okay, well that must not be the name of their protest. Yeah, I think that was the lead truck. Interesting. Well, anyway. Yeah, going back to, yep, video's still going. Okay, going back to what I was talking about. So, that's pretty much what you get with gyroscopic properties in DRCBs. I wanted to make sure I got that all out there. The thumbnail that I'm going to put onto the lead of this, and the credit goes to NASA, the SDO, because obviously I don't have any way to take that kind of a photograph of the sun. And you know, I'm really glad that we have something up there that can take photographs like that of the sun, because it gives us the opportunity to actually capture these principles of operation. The name of it is double prominences or something like that. So when the SDO took the photograph, they weren't even photographing it for the sake of this bright flash, this singular bright flash at the right smack in the middle of the sun. They're taking it, taking a picture of the prominences, and that's when you look at the sun's horizon around its edges, you see solar flares blasting out from the sun's surface, and then that's what they're referring to as prominences, the solar flares. But what they apparently are not seeing is the importance of that single flash of bright plasma smack in the center of the sun. And that plasma is extraordinarily close to the perimeter, or the perimeters of the left vortex and the right vortex as you view them when looking at the picture. We don't know if it's the western or eastern hemisphere, because how do you keep track of that on the sun, right? You just know it's the left and the right. And they both happen to be rotating in opposite directions, which, when you come to the tangents of the 245-degree radial perimeters, they're flowing together, and that creates a flowing tangent which does not have a lot of craziness going on per se. And we wonder to ourselves what it is about the sun that works so twisted and binds up all of this electromagnetic energy in the form of ropes, twisting them around and turning them into coils and things of this nature, right? Well, I'm going to tell you, it's because of the 6 primary vortices connecting together, creating the 3 vortical rods, in addition to the alternating flows of the Jupiterian stripes, which might be a lot harder to see on the sun. I haven't really tried looking at the sun to see if I can identify those as much. As far as I'm concerned, just the fact that I was able to establish some kind of recognition and identification of 4 of the primary vortices is substantial enough, and it supports my gyroscopic theory of the operation of planets. Now on Earth, you have a fracture, and that fracture, you have half of that fracture is the mid-Atlantic ridge, and the other half cuts through the Pacific Ocean. Now, if you look at the globe as a globe, these fractures, as I refer to them collectively, the Atlapac fracture, in the globe sense, or the globular view of the planet, they tend to look like they split the planet in half, but the truth of the matter is they don't split the planet in half. If you look at a panoramic type of a photograph of the Earth, say for instance Google Maps versus Google Earth Pro, you can see that the Atlapac fracture is only basically cutting the Earth into a particular piece of pie. It's only just a percentage of the Earth's surface, and it separates the greater continental masses of Asia, Eurasia, Europe, those guys, and the others out there, Australians, whatnot, from the Americas. The Americas, oddly, seem to be kind of like they're on their own island of crustal mass. And if you want to call that tectonic plates, I suppose you can, but it's not necessarily functioning in terms of being a plate. I haven't exactly figured out what the primary importance or event that affected that fracture to come into existence was. However, what I can say is, at one certain point in time, the Earth had an impactor strike. And I wanted to read my notes, my penciled notes. I figured out the diameter, what the diameter would have been of that impactor. And if I'm not mistaken, the impactor's diameter came to about 8.4 kilometers. So it's really, when you think about the whole size of the planet, 8.4 kilometers isn't really that large. That is an impactor that is smaller than Hohenfels in Germany, the Hohenfels training area. That one, the Hohenfels training area from one end to the other is 15K. So, or 15 clicks, right? So it's 8. This one would have only been 8. And there's no guarantee that it was a spherical object when it impacted. It could have been a shard. It could have been any kind of funny looking shape. But at some point it was probably 8 kilometers at its greatest length, if not that being the diameter. And how did I come to that conclusion? Well, I'm taking meteor crater and past scientific research establishing that the probable size of the meteor that created meteor crater upon its impact would have been approximately 30 to 50 kilometers in diameter. So we go to the center of that and we call it 40. So basically, all of my estimations of impactor dimensions are going to be based on meteor crater. There's your control. It's, depending on how accurate the scientists are in their determination of meteor crater's actual diameter, that's what you go by. So, you have all kinds of different impact craters. Meteor crater is a depth burst. That means that the impactor penetrated the Earth's surface and burst beneath the Earth's surface. It did not burst at the moment of impact. It did not burst before the moment of what would have been the impact, which would have been an air burst. So it was not an air burst. it was not a surface burst, it was a depth burst. Oh yeah. I'm in that zone. What zone? Oh yeah, I'm into gas curves. Got to keep track of where I am on the freeway here. Don't want to do what I did the other day where I passed my off-ramp and I'm like, where am I? Uh-oh. Ah, crap. I had to turn around and go back. I made it to work on time. Good thing I left early enough. Alright, so basically the world would have had to have entered into some state or condition that would have allowed it to have been somewhat malleable so that the forces that lie beneath the Earth can actually affect the surface of the Earth. And this is what I'm referring to as worldwide liquefaction. And so basically the largest impactor to have ever struck the Earth that is just as clear as a bell, if you think about its appearance, you have to take into consideration its magnitude. And I'm telling you that that's basically Indonesia. So we're like, well, Indonesia has like this ring of earthquake activity going on. Well, yeah, because the magnitude of this particular impact was so great at the time that it occurred that it literally caused a chain reaction of events. That one of those events was the state of worldwide liquefaction, to the extent that these vortical centers around the equator and the North Pole and whatnot began to rotate at the surface. And that means that some of these vortices would be rotating faster than the others, quite possibly, just depending on what the driving force is. And it just so happens that Indonesia's impact crater took place north and northwest of, or maybe north and west, northwest, you know, still northwest, right, of the North Banda Basin vortex. And the North Banda Basin vortex is already rotating. So when that burst exploded, it displaced a huge swath of earthen material, including material lying within the mantle. And when that material returned and filled in that void, it took the property of rotation that was already going to be driven by the North Banda Basin. So like a gear, it starts rotating in the opposite direction as the North Banda Basin. And its force and this binary relationship between the two vortices was so great that it actually caused smaller vortices to appear in the surface of the Earth around the center of North Banda Basin's core, presenting a pentagon shape in the surface of the Earth at that very core. And that impact had such a major effect on the Earth that that particular binary vortex is still operating today. And it's more active than the other vortices at the surface. And that's why you're getting a lot of earthquakes in that region, right around the rim of that vortical perimeter. And I understand that that vortical perimeter is nowhere near equal to the 45-degree vortical perimeters of the primary vortices around the equator or the poles. And then you get the other chain reactions of vortices. You end up with let's see, what direction is the North Banda Basin rotating? Now the North Banda Basin is rotating clockwise, which means the Indonesian vortex is rotating counterclockwise. And likewise, the Fiji Island vortex is rotating counterclockwise, which in turn is rotating and mating with the New Zealand vortex, which is rotating, let me follow my thing here. You got counterclockwise, clockwise, counterclockwise. New Zealand's rotating clockwise, which is connected and mating up with the Antarctic polar vortex, which clearly is rotating in a direction that is counterclockwise. So there you have it. You have this rotating vortical chain going all the way down to Antarctica. So all of those activities you see taking place down there, that's what you're looking at. When you're looking at Hokkaido of Japan in the north, and you're wondering why the Earth slipped in the direction that it did. Well, it just so happens that Hokkaido is right up there along the northern arc of the, let's see, which vortex is that one? That one would be the North Banda Basin vortex. So the northern perimeter of the North Banda Basin vortex cuts right through or right around the region of Hokkaido where that earthquake took place. And that's why the Earth is moving toward the east. If Hokkaido was in the southern hemisphere, the earthquake would have been moving that material toward the west. So if you think about it, there's a lot of sensible information that I'm giving to everyone here about how these vortices work. So not only am I explaining how the Pacific Oceanic Vortex runs right along the San Andreas Fault, which is separating the Gulf of Mexico right on up through San Francisco apart from North America, but I'm also explaining how and why the Earth is moving in the direction that it's moving up in northern Japan. So we can either take this information and make the best sense of it that we can while we can, or continue to think that the Earth's surface moves in the form and similar fashion that we see clouds operating in the sky. And that really isn't necessarily the case. Then you have, I did mention the coefficient of solar wind pressure and how the continents are spiraling down toward the South Pole, and as they do, they thin out, and as they thin out, they develop the continental form that appears to be similar, extraordinarily similar, to Virga falling from the clouds. And that's because the gravitational force toward the base of the planet, the South Pole, is greater than the gravitational force at the North Pole. Now, that's not the gravitational force that we're talking about that's being generated by the planet. That's the gravitational force that's being shared toward the planet by the supermassive electromagnetic gravity waves that are flying around the galaxy that are generated by our parent black hole, BH number 1, of the 3 black holes at the center of our barred galaxy. That's where you get the greater force. You have a greater force that's flowing up and against the galaxy, which makes the other side of our galaxy, where we don't exist, a flatter structure than the top of that galaxy, right? The MOG. So the top of the MOG is much, much more bulbous than the bottom of the MOG. That's because universal jet streams are blowing up against the MOG, which gives the MOG its obliquity in relation to the universal plane. Yeah, our universe isn't round. It's not infinite. It's a vortex, and it probably functions more like a hurricane functions on Earth, where you have an eye of the storm, and around that eye you have jet streams flowing in opposite directions. Only in the universe, just like you see with planets, it's not flat at the base of the vortex. The base of one vortex is met by the base of the opposite vortex, which turns the universe into a donut. So you have these universal jet streams that are more in the shape of rings, donut rings, than they are in the shape of just jet streams flowing around on one three-dimensional aspect of the overall structure of that system. So you basically have the double system. Planets are a double system. They're a four-dimensional projection of energy that gives you a north and a south. It gives you the vortex in the north, and it gives you another vortex in the south, and when those two vortices join together at the core, they make a vortical rod. And then when you look at these objects from outer space, you see a ball. You don't see each and every one of these individual vortices, you just see a great big ball. Well, maybe they're not all great big, but to us, in relation to us, in most cases, they're pretty much great big. Okay, so enough about talking about balls. So we have a construction truck up here flashing his hooply-doos, and traffic's getting pretty dense. Everybody wants to go to work today for some reason. Oh, that's right, because it's Monday. First day of the week. People only go to work on the first day of the week. I don't know if that happens everywhere else, but if you live in Washington, up here around the Puget Sound, that's the case. People only work on Monday because that's the only day of the week at the same time that I go every day of the week. It's the only day of the week where there's dense traffic. Don't ask me why. Apparently that's the only time of the week where everybody's worried about getting to work on time. Every other day of the week they couldn't care less, and so there's nobody on the road, and you're wondering if you didn't get the memo because you're like the only dude driving to work. You're like, what's going on? Is everybody on vacation? I mean, what happened here, folks? Am I doing something wrong? I don't know. Maybe I am, and if I am, I'm liking it because I don't like driving in a bunch of traffic. I prefer to be left alone. Well, I must be dragging my butt because this guy's passing me up. Big old truck passing me up. So what the heck? I can drive faster than you can. Hey, stay in your lane, yo. You can't come over yet. Now you can, because I'm merging right again. Another lane just added to the freeway. Woo! Well, okay. Now I've done a lot of talking about DRCBs and explaining how they function. And I delved a little bit in a previous video when I talked about white holes basically being nothing less than black holes because the stellar masses buzzing around them are so much more plentiful of stars that the white hole, as it would appear to be a white hole, is a black hole, because it's still a lower luminosity than its stellar subjects. What you can understand is, because the volume of stellar subjects is so much greater, it has a near constant feed, a near constant rate of feed that fluctuates very little, I would have to say. And since it fluctuates very little, it creates a near cyclic emission of gamma ray bursts as each one of these bright TSOs, BTSOs, maybe we call those bitsos. So as these bitsos can only hold so much energy up to the extent of their electromagnetic bubbles, that energy has to be expended in the form of gamma ray poop. So they're eating stars, so they're eating all of this energy constantly until finally their electromagnetic bubble guts get too full and they have to poop gamma ray bursts. And they're going to poop gamma ray bursts through the weakest points of their electromagnetic bubble guts. So they're going to have the tighter, more dangerous gamma ray burst coming out of the South Pole. That's usually our case, right? Because the thicker poo comes out of the bottom and the lighter poo comes out of the top. Usually you don't see chunks of poop coming out of your throat. So it's kind of the same thing with these gamma ray bursts, right? And we have to understand that because these bitsos live around and congregate around the center of the universe with this much, much higher volume of stellar rate of stellar feed, they're going to burst much, much more often. And they're going to be rotating. And it's because of their rotation that these gamma ray bursts that they poop are being spiraled out at high speed and at a tighter diameter through the South Poles than through the North Poles. So that means that the South Pole GRBs are going to have a far greater range. And because light is because light is a particulate and it actually has a mass, it's got to have a mass, right? So it's a particulate running through space, and our eyes give us the ability, in most cases, to see this same spectrum of light that is emitted from most of these things. We can't see the gamma ray bursts, but at least, well, maybe we can, because we're sitting there looking at it's either the magnetars or the pulsars, something like that, that are bursting gamma ray poops that we can see, and they look like those rotating lights on the ends of the airfield. Are they on the ends of? Oh, no, they're not at the ends of the airfield. My bad. They're at the air control tower, right? So that's basically what you get there. But that may not necessarily be the case, because it's not a continuous beam. It's a poop. Nobody poops continuously. They just poop until the poop stops, and then they fill up their gut and they poop again. So stellar stars that have this capacity to hold a high volume of beta decay that ends up very quickly filling up their electromagnetic bubble guts, they poop more often. And they're creating their own energy from within. So their cycle of pooping really is cyclic. It's not near cyclic, it is cyclic. It's based on the rate of decay of their beta decay, and it's a consistent measure of how many times they fill up their bubble gut before they poop. bitsos, on the other hand, and black holes, they just they don't poop quite as regularly. They can't poop that off. Whoops, I better get onto the freeway before I end up getting off the freeway. I'm not paying attention to where I am. I was beginning to wonder why there were 3 lanes, and then it dawned on me, this freeway doesn't have 3 lanes. Yeah, I better move over. I'm going to get stuck going somewhere I don't want to go. Alright, so anyhow, that's how we have it. Now we got a fast mover. He wants to play tag with me. I'm going to have to slow down because I got merging traffic. But he moved over in time, so he didn't do so too crazily. Probably driving a little too fast for the conditions, but not to a point where he's out of control. Well, anyhow, that's what we're looking at, folks. Now, why am I talking about the center of the universe and things like that? Well, it's at the center of the universe where you're going to find these BITSOs. They're going to be near cyclic. So now they may have a property that's even more akin to the distributor cap in your engine. And they have a firing order. And this near cyclic firing order helps continue the rotational property of our universe. So it gives longevity to the life of our universe. But in the same time that it's giving longevity to the life of our universe, it can be extraordinarily dangerous as these gamma ray bursts are shot through the universe, and in the case of the Earth, could even be having near catastrophic proximities as their trajectory takes them past and close by our solar system, if not, very dangerously close to our galaxy. And why am I leading up to that? Well, because there's certain things that take place, like in 2010, we recognized, and when I say we, I'm talking about scientists out there that probably do have credentials, that recognized that there was an extragalactic gamma ray burst that passed by our solar system. And in its passing of our solar system, in and around June of 2010, it knocked out one of our satellites for a while before the satellite was able to recover itself. Okay, well, we had a couple other anomalies take place around the same time frame. And when we're talking about BITSOs at the center of the universe, I'm telling you that we might think that the black holes at the center of our galaxy are massive. Well, if the black holes at the center of our galaxy are massive, then you can pretty much bet your bottom dollar the BITSOs at the center of our universe, if they're strong enough to be like distributor caps, and probably there's going to be 5 of them. And they're all siblings, 5 siblings, buzzing around the center of the universe lie. They're going to be a heck of a lot larger than anything we've ever seen. Or not seen. Since we're calling them black holes, right? Because we can't see them. So, they're going to be something more like mega massive black holes, or mega massive in relation to our black holes as we're accustomed to. And their establishment would have been so much earlier in the birth of the solar system, in the birth of the universe, right? That they've had ample time to add to their mass, especially if they are continuously fed extraordinarily high volumes of stellar mass that are just coming to life, lighting up, and being eaten at the same, no sooner, like bugs, just hatching like crazy, and then they all congregate around that light bulb, and then they get zapped by the light, or cooked or whatever by the light bulb as they fly into it, right? And it's just like, I don't know, it's kind of like a plague, like it was all these moths. When I was in Afghanistan, there were so many moths, you didn't want to breathe for fear of sucking one into your lungs. That's how thick it was. And they kept buzzing around the bug zapper. And that bug zapper it stunk too. But that bug zapper was cooking them left and right. Pop, fizz, pss, and all this other weird noise. And it was endless. That's what these stellar masses are doing. There's just so many of them. It's like this plague of moths that popped up, and it's continuous and it's constantly feeding these mega massive bodies of mass that are mostly terrestrial in nature, and quite a bit less likely to be stellar mass, but enough stellar mass to make them brighter and basically be your white holes. So yes, if we want to ask the question, are white holes more than just theoretical? Yes, they're absolutely more than just theoretical. They exist because the rate of stellar feed exists. And it's that rate of stellar feed that's going to affect the luminosity of that black hole. It just depends on your relative opinion of what bright is. Until you determine a specific level of candle power to describe that brightness, it's anybody's guess to what bright really means. It's kind of like when you make laws. Laws cannot be ambiguous. They must be very clear in stating precisely what it is that their meaning is to be understood, in establishing a set norm for that particular society to follow the law. And if they can't be in clear terms to be understood by people, then it's not much of a law at all. It's vague and relative, and those are the laws, and they are out there. There are vague and relative laws, and that's why people are able to go to court and challenge those laws under many different situations, because new thought processes come into play and arguments become better as time progresses, and really people evolve to be a little bit smarter than they used to be. That's pretty obvious. I mean, every time a new person comes up, they have newer and better ideas, and that's how we are able to technologically advance the way that we are, because literally we are getting smarter. But it's not a very quick process either. It just happens. And I forgot how that correlates with Bitzos toward the center of the universe and whatnot. All right. Yeah, I'm being a terrible yo-yo. I haven't paid any attention to how I'm driving or my speed. And I'm pretty much following the traffic here. And, you know, it's frustrating when you're in the left lane and you pass somebody and they're being a yo-yo and they speed up and then they're suddenly right next to you again. You're like, what? I passed you, man. Okay. Well, I'm getting pretty close to work and my recorder's still going. Oh, there's so much to talk about. And now, after I started thinking about it, I remembered when I traced the Jupiterian stripes. The four most prominent sets of Jupiterian stripes both came out to be 9, and I have no problem believing their existence. Then I came across what appeared to be a Jupiterian stripe score, and I tried to use basically what would have been my forensic, if you want to call it that, opinion of how those Jupiterian scores took place. And as a result, at the end of tracing the remnants of what this Jupiterian scored process presented, I ended up with 11 Jupiterian stripes versus 9 Jupiterian stripes. So that leads me to believe that at some point in time, in the beginning of Earth's establishment as a planet, it was rotating faster. And it was rotating at a rate of 11 Jupiterian stripes versus the current rate of 9 Jupiterian stripes. So I explained that some kind of catastrophic events had to have taken place when some kind of catastrophic event had to take place in order for the Jupiterian stripes to have been etched into the planet's surface as a record of that event. I only can see 2 very obvious impact sites, which current scientists don't really agree to me is even possible, but I'm going to show how it is possible, and I'm going to explain and describe the similarities between all of these sites and how they correlate with crater analyses that are used by the military to trace and track down enemy units that fired indirect fire weapons toward us. And it's a proven method, and it's going to be the same method that we use to determine where the origins were, or the poo is, in relation to each of these impact sites, right? And the poo is the point of origin. And that gets kind of more complicated, and I can explain it in words and terms very easily now. I mean, it wasn't so easy before, because I never really measured trajectory before. That's kind of a new thing. Military doesn't care about trajectory. All they care about is the back azimuth and the range to determine the approximate location of the enemy unit that fired that weapon, right? And depending on the type of round that impacted and burst, which is also, we can determine that based on the shrapnel left behind. You know, you determine what the weapon system was that was used to fire at us. Well, it's the same thing when you're looking at meteor impactors or meteor impact sites, where you're looking for the remnants of that meteor to tell you what that meteor was made of when it impacted. And in the Earth's atmosphere, you have something that we call deflection. And the chances are that when some of these events occurred, as catastrophic as they were, in order to set the world into a state of worldwide liquefaction, we may not have had an atmosphere that would have been thick enough to effect that impactor in terms of deflection, which gives that impactor a greater capacity to strike the Earth in a more direct order, as it did in the case of, or very much so, in the case of the Indonesian impact. And yes, you can look at that Indonesian impact crater and see that it's in the shape of an oval. Ovals tell us that the impactor had an angle, it had a trajectory, and was not necessarily actually a steel-on-steel direct hit. That bugger had an angle as it struck the Earth. The difficulty with ovals is you may find it difficult to determine exactly which direction of 2 that back azimuth really came from. So instead of having one possibility, you have 2 possibilities. There's a red flashing light there, and it's like, where's that red flashing light come from? I don't see anything flashing red anywhere. Okay, well, anyway, That's how things go together. Yeah, I'm running out of wind. I mean, I have so many things to talk about. And the one thing, back to the Jupiterian stripes. Before I get to work, I really do want to mention this. So I traced 3 sets of Jupiterian stripe scores. The 2 of the most prominent, which I have no problem believing, and because they also coincide with Jupiter's current Jupiterian stripes. So we know there's a relationship there. Now the 11 stripes, anytime you see stripes, you know that it's the same thing as when you're stirring the the swirls you see when you're stirring eggnog and stuff like that. The faster you stir your the faster you stir your eggnog, the tighter the cinnamon spiral, the spiral density cinnamons go around in circles, right? So that's the same thing with DRCBs. The faster they rotate, the more numerous their number of Jupiterian stripes. So it only goes to say that it seems logical that in the beginning of the Earth, when it had been coalescing initially in its formation as it came to its coalescence at the beginning of our solar system and being born as a planet, you had a faster rotation. That makes sense. But you see, it's BH number 1 that is responsible for driving the rotation of the sun, which is responsible for primarily driving the rotation of the planets. And so if Jupiter had 9 stripes, or has 9 stripes now, its rate of rotation is Jupiterian 9-stripe rate of rotation. The sun is at a Jupiterian 9-stripe rate of rotation, which tells us that BH number 1 is at a Jupiterian 9-stripe rate of rotation, which ultimately also tells us that the PBH, the parent black hole at the center of our galaxy, which is larger than both the siblings, is also rotating at the Jupiterian 9-stripe rate of rotation. So that means ultimately our galaxy was rotating faster if the 11 stripes of Jupiterian stripes that I believe I could very well have forensically identified. That means that the planet was in fact rotating faster when at least one of 3 catastrophic events occurred in Earth's history, allowing these scores to be recorded in the surface. And that means that the Earth was rotating faster, the galaxy was rotating faster. Now, there was another instance where I felt like if I pinned the tail on the donkey, and what I mean by that is I stood back and I looked at a world map, and I, in my mind, envisioned crushing all of the mass of continents back together into one continent, to be in my mind an imaginary Pangea continent, right? Then where would I pin the tail of the donkey if it was the center of this mass? And when I did, my finger landed at the northern shore of the Caspian Sea. So I started to look at that more closely. And if you look at the Caspian Sea, it has the Earth around the Caspian Sea has the proper vortical structure that you would expect to see if at one time in the history of the planet the Caspian Sea was in fact like the very first North Pole. So then I started to develop what I would believe, based on terrain features that I was apparently able to see at the time that I was doing it. I ended up with a set of 13 Jupiterian stripes. And if that's the case, then basically at the time, somewhere around the time when Pangaea existed, when the Earth basically would have sealed its planetary sutures and pretty much solidified the world around, that would have been when the north end of the Caspian Sea would have been at the North Pole, right? And now, the thing is, even though, however, I came to the number 13 when determining these theoretical Jupiterian stripes from Pangaea's North Pole, it's not really, I was looking at it again, and they're just not really that visible. Certainly not as visible as the most prominent two sets that put us into the 9-stripe period. So you got a lot of things going on there, right? But if it is true that could be the case, and those theoretical stripes could be evident, then that means that the planet was actually rotating at the rate of 13 Jupiterian stripes. And if the Earth was rotating at the rate of 13 Jupiterian stripes, that actually means that one Earth day was equivalent to 16 hours and 34 minutes. And if you think about the length of time that we so far know the Earth to have existed in its solidity, it comes to about 4.4 billion years before present. 4.4 billion years ago, the Earth rotating faster at only 16 hours and 34 minutes. That's not really that great of a difference than what it's rotating at its current near 24-hour period, right? So these are things that you could always take into consideration. But then again, you see the Pangaean Jupiterian stripes are simply theoretical. I have to look at them more carefully to see if there's really anything that I could say to the world, hey, this is what I'm looking at, and this is where I come up with this idea, right? I'm not quite sure. I got to go back. It was so long ago that I did it. I also found Jupiterian scores, what appear to be Jupiterian scores that are in the Indian, is it the Indian? Yeah, they're in the Indian Ocean, and I was like, I'm going to trace these. So I traced them. And when I was finished tracing them out, I don't remember how many scores that it came to, but when I was finished tracing them out, I was upset, actually, because they were shaped in the form of a letter U, kind of. Not exactly as, U-shaped, but more like a shallow bowl. And I looked at them, I was like, no way. There's no way those could be Jupiterian stripes. So, me and my infinite wisdom, I deleted those stripes off of Google Earth. And now I'm beating myself over the head because now I'm thinking that the largest impactor to ever strike the Earth could have been large enough to have the magnitude to knock the Earth clean off its rocker and cause the planet to actually have an extreme precession that is not as circular as much as it is in the shape of an ellipse. So these are things to take into consideration. Now, if you take into consideration possibly the speed of the Earth at the time that it would have impacted, say if it impacted the first time, and it was the first one to strike the Earth, and it hit the Earth when the Earth was rotating at 16 hours and 34 minutes a day, and it hit, and it was 8.4 kilometers in diameter, leaving a crater the size of Indonesia, then that could easily have had enough magnitude to knock the planet off its axis catastrophically, along with a few other chain events. And I'd like to go into those, but time's up now, so I'm going to go ahead and let it go at that. I'm going to have to retrace those rockers, and if I retrace the rockers and find that it looks the same as it did the first time I felt I traced them, then we're onto something. Because if I could go this far in between tracings and come up with the same result, then I'm onto something. If I can't, then I was full of, you know, BS, like a lot of people would like to think. All right, so I'm gonna let you go, guys. It was nice talking to you. It's really dark out here, so I'm gonna go inside where the lights are, okay? Well, the lights in the parking lot are on this time. Okay, but been nice talking to you. Bye.